The following program is video supplemental instruction. VSI is brought to you by the Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.
Welcome. You're watching number 14 to Chem 2045, Fall 2009 Exam 1. Oh yeah. It says that when iron ore containing the mineral hematite is allowed to react with carbon monoxide in a blast furnace, cast iron and carbon dioxide are produced. What is the percent of Fe2O3 in the iron ore if 1.64 times 10 to the third kilograms of Fe are obtained from a 2.62 times 10 to the third kilogram iron ore? And assume that you have enough carbon monoxide in order to react all the hematite out of the ore. So let us develop an equation for what's going on. It tells us that the hematite, the Fe2O3, is allowed to react with carbon monoxide in a blast furnace containing, and then cast iron, solid, doesn't really matter, and carbon dioxide are produced. CO2 gas, and carbon dioxide gas, and this is solid. So then we have to balance this. Okay. Now this is a little bit unorthodox of a reaction, and everybody has their own way of balancing. So I'm going to do it my way. Alright, I see that two irons, I need two irons here. I have one carbon, one carbon. Always save your oxygens for last, because they're always tricky. I have four oxygens here, I have two there, so I need a total of four oxygens now. Oxygens are good, but now I have two carbons, so I need two carbons there. Now I have five O's, so I need at least five O's here. Let's move this up a number. Now I have six O's. Alright, but I can make this six O's. And now the carbons are good, irons are good, oxygens are good. So hopefully you can also balance this without freaking out. It's very easy to, unfortunately, except freaking out. Balancing takes practice. Alright, so then what we're given is we're given the amount of iron that was produced, and we're given the amount of ore that we started with. We're trying to find out how much Fe2O3 there is in this amount of ore. What percent of the ore is Fe2O3? Let's backtrack. We can say, based on the amount of Fe produced, I can find out how much Fe2O3 must have reacted away. And then I can use that and divide the ore into it, and then I have a percentage. So let's hop to it. Let's start out with what we're given. 1.64 times 10 to the third kilograms of Fe. I need to convert to grams because kilograms is useless in chemistry. Kilograms to grams. For every 1 kilogram, I have 1,000 grams. Kilograms cancel. Now I need to cancel grams Fe with something. According to Mole World, where mole A can take me to grams of A, or moles of A can take me to atoms of A, or moles of A can take me to moles of B. According to Mole World, these are my options. I'm here at grams. I can only go to moles, so why not? So moles of Fe, for every 1 mole Fe, I have 55.85 grams of iron. Grams cancel. Now I'm at moles of iron. How many moles were produced? I know it now. I see that for every 2 moles of iron that were produced, I must have had 1 mole of hematite to start with. So, moles of Fe, and then I'm looking for moles of Fe2O3. It's a 2-to-1 ratio. Moles Fe cancel. Now, let's take those moles of Fe2O3, let's convert them to grams. Fe2O3 because that's what I'm interested in. I need the grams of Fe2O. Actually, I need the kilograms of Fe2O3. Moles Fe2 cancel moles Fe2. For every 1 mole of Fe2O3, I have, oh boy, that's a big one. That molar mass is 159.7 grams Fe2O3. Let's convert to kilograms. For every 10 to the 3rd grams, I have 1 kilogram. Grams cancel. And punching this out, we have 23 44.7 kilograms of Fe2O3. Alright? This is how much Fe2O3 was in the iron ore. Let's see what percentage this is of the whole iron ore. 2344.7 kilograms Fe2O3 divided by the whole iron ore. 2.62 times 10 to the 3rd kilograms. Make sure that you're in the same units here. Although you can't divide grams by kilograms. Kilograms will cancel, multiply by 100%. And you end up with 89.5%. So that iron ore is 89.5% Fe2O3.
The Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.